Everyone, and welcome to this new course, which is Electrical A1 Circuits. This course is required to pass the professional engineering requirement at Canada. So the circuit exam basically will have usually 6 questions covering 6 different topics. So what I'm gonna do, I will take each topic, I will cover the basic concept of it, and I will solve 2 questions from each topic. So we'll start with the question 1, which is the circuit reduction. So this is the question appears in December 2019. And basically it asks for the equivalent circuit or equivalent resistance between 2 points, RAB. So the resistance between point A and point B. What is the equivalent resistance? And then the questions will ask to find a voltage or a current in the circuit. So I will have 2 different questions with 2 different basically approaches to solve these questions, and that covers, you can say, most of the questions in that specific category. Before we start solving this question, let's try to have some background for those who forgot some of the basic concepts. So we'll start with series parallel connections. How to identify if the resistors are connected in series or in parallel, and how to find the equivalent resistance. So let's start with the series connections first. So basically when you have a resistance R1 connected to R2, we said that these 2 resistors are in series when these 2 resistors share one node, which is this node, and nothing else is connected to that node. Then we say that R1 and R2 are in series. In other words, if there is a current I that goes through R1, is the same current that will go through R2. And R equivalent for the series is equal to R1 plus R2. And if you have more resistors in series, you just add them. Now, in parallel, when you have the 2 resistors sharing the 2 nodes, okay? So this is R1, and this is R2, and this is node 1, and this is node 2. So when the 2 resistors sharing the 2 nodes, then we said that they are in parallel. You could have more resistors as well, R3, R4, and so on and so forth. Now, to find the equivalent resistance, 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and so on and so forth. As a special case, if you have only 2 resistors, R1 and R connected in parallel, so we will have 1 over R equivalent is equal to 1 over R1 plus 1 over R2. So this is equal to R1, R2, R1 plus R2, or your R equivalent, take the inverse of this, will be R1, R2 over R1 plus R2. So if you have 2 resistors in parallel, the equivalent resistance, you multiply these 2 values and you divide by their summation. Now, this is if the circuit has only resistors in series and in parallel. But sometimes, and in that question, after I did a scan for around 20 exams, it is always neither in series nor in parallel, but they are connected in something called Y connection or delta connection. And you cannot identify any circuit or any resistors in the circuit as either in parallel or in series. And this will lead us to the second important topic, which is the delta Y conversion. Now, in the delta conversion, if you look here, this is B. So ZC, ZA, and ZB, don't look to the inside here, just look to the outside here. This is connected in what we call in delta. So what is a delta connection? A delta connection that when the end of one resistor is connected to the beginning of the other one, and so on and so forth. And you will see that in all the questions we will have, you will see the delta connections there. And in the delta connections, as I will identify this to you in the question, you cannot find any two resistors in series or in parallel. So how to avoid this problem? You convert the delta into Y. You could also do the Y into delta, but I think only knowing delta to Y is sufficient to solve any question. So there is no need to do the rest. Now, how to find the equivalent Y? Now here, this is the equivalent Y of the delta connection. So basically, you will remove the delta and substitute it with the Y connection. Now in the Y, Z1, for example, is equal to the multiplication of the two adjacent delta connected resistors divided by the summation of all resistors. So Z1 is ZB times ZC divided by the summation of all the three resistors. Z2 is the multiplication of ZA and ZC divided by the summation of the three resistors. Z3 is equal to ZA times ZB divided by the summation of the three resistors. Now, these formulas are, if you want to do the opposite, meaning going from Y to delta. As I said, there is no need to work on those. These will be sufficient. And these formulas are given into the exam, so you don't need to memorize them. Now, let's go to the question. In the question here, it has two parts. First, I want to find RAB between point A and B. There is nothing, no sources connected. So let's forget about part B now. So I want to find the equivalent resistance. The first thing in such a question, identify the nodes. Let's number the nodes. So here, this is node number 1, or 2. Now, a node is a point connecting two or more elements. Now, this is, sorry about that, is also 2. Why? Because there is no element between these two. This is 3, 3, 4, 5, 5, 5, no elements here, and 5. So we have 5 nodes. Now, do we have anything connected in series? You look here. For example, let's look to the 5 ohm and the 10 ohm. This 5 ohm and 10 ohm. They are not in series. Yes, they share one node, but this node is shared by the 10 ohm as well. And if you look to the whole question, you will not find two resistors that sharing one node and nothing else sharing that node. Also, there is nothing in parallel. There is no two resistors sharing the same two nodes. For example, the 250 and the 100 and the 10 ohms. The 25 ohms is between 3 and 5. The 10 ohm between 4 and 5. The 20 between 2 and 5. The 5 between 2 and 4. The 12 between. So there is no two resistors with the same number of nodes. So whenever you have such a stagnant circuit that you cannot do anything, you cannot reduce it, you cannot do any parallel series combination, then the only thing you have is to do the delta Y conversion. Now, we have here multiple deltas. This is a delta connection. How do I know this is a delta connection? Because the starting of one resistor is connected to the end, the starting to the end, the starting to the end. So this is a delta. This is also a delta connection. This is also a delta connection. This is also a delta connection. So we have like 3 delta connection resistors. Now, how many of those I need to do the conversion? From my experience, only one will suffice. And this will make the circuit much, much easier. So I will take the top one. And I'll come from here. I will have one resistor, another resistor, and a third resistor. So we have here our resistors that as R1, And then here we will have our R2 and R3. And you will see that so when you connect this, you will cancel the delta connection completely, and you will have only the Y connection. Okay, so we have R1, we have R2, and we have R3. Okay, and how to find R1? Your R1 is the resistance between the 12 and the 5. So this is equal to 5 times 12 divided by the summation of the three resistors, the 5, the 12, and the 10. It's 5 plus 12 plus 10, and this will give me 2.22 ohm. Then let's see R2. R2 is basically between 10 and 5. 10 and 5. So your R2 is equal to 10 times 5 divided by the same resistors, 5 plus 12 plus 10, and this will give me 1.85 ohm. Finally, my R3, which is this resistance between the 12 and the 10, will equal to 12 times 10 divided by 5 plus 12 plus 10, and this will give me 4.44. So these are the three resistors. Now, let me redraw the circuit after this conversion, and you will see now the resistors will start to have much more sense. You will still see that the resistors that you can now add them in series and in parallel. So let me redraw the circuit now, or what I will do here, I will just redraw this and remove the other. So I will draw the whole thing. So I will have here my, basically, this is my R1, R2, and R3. So I will draw it here. This is my R1, this is my R2, and this is my R3. We know all the values of this. Now, as I said, this gun, this is gun, and this is gun. So now your R3 is connected to the 25 ohms. 25 ohm. Your R2 now is connected to the 10 ohm. 10 ohm. Now this connection stays the same. And then your R1, this one is connected to the 10 and the 20. So we will have here 20 ohm, 10 ohm, and I want to find this equivalent resistance between point A and point B. Now, my R3, as we know it, is equal to 4.44. My R2 is equal to 1.85, and my R1 is equal to 2.22. Now, let me number the nodes again. So this is, let's say, node number 1, number 2, number 3, and this is number 4, and this is number 5. So clearly that R3 and the 25 ohm, they are in series. Why? Because they share this node 3 and nothing else sharing that node. So I connect these two resistors basically in series. So I will have here, and in series meaning what? I will add them. So I will have here 29.44 ohm. So these two are connected together. Now when I connect them, this will be node number 2, the beginning, and the end will be node number 4. Node number 3 is between the two nodes will be dissolved because I added the two resistors. Then R2 and the 10 ohms are in series as well because they share node 5 and nothing else share that node. So we will have here another resistors, and this will be also between 2 and 4, and the value of this will be 11.85. Then I will have here the 2.22 ohm. I will have here the 20 ohm, and I will have here the 10 ohms. So you see the circuit now becomes much, much easier to analyze. Now, this and this, they are in parallel, the 29.44 and 11.85, because they are sharing nodes 2 and 4. So I can change this into one resistance. So I will call this is R equivalent 1. So R equivalent 1. Now, because there are only two, you multiply them, divide by their summation. So 11.85 times 29.44 divided by 11.85 plus 29.44, and this will give me 8.45 ohm. So all of these resistors, now we can have it as only one resistance. You redraw the circuit, and that is what I strongly suggest. Every time you do a reduction, go and redraw the circuit. So we'll have here 8.45 ohm. So this is node number 2. Now, when you add two resistors in parallel, the two nodes will stay the same. This will be between 2 and 4. We have the 2.22, the 20, and the 10. This is point A and B. And clearly what you see that this and this, they are in series. Why? Because he's sharing one node and nothing else shared that node. So I will call this R equivalent 2. So R equivalent to, you just add these two resistors. So you'll have 10.67 ohm. Okay, let me continue now. And let me redraw the circuit again. So what we will have here, you will have 10.67 ohm between node 2 and node 4. And then you will have here 20 ohm, and you will have the 10 ohm. That is the final circuit. So this is 2, 2, 4, and this is node 1. So these two basically very clear they are in parallel. So I will call this R equivalent 3. So my R equivalent 3 is equal to 10.67 times 20 divided by 10.67 plus 20. And this will give me a total resistance of 6.96 ohm. So this will be equal to 10 ohm, 6.96 ohm. This is node number 2. Okay, this is 4, and this is 1. This is A and B. And then finally, the R equivalent, very clearly the 10 and the 6.96 are in series. So this is 10 plus 6.96 ohm, which is equal to 16.96 ohm. And this is the total resistance between point A and point B. Part B. Now, when I connect a 50 volt here, so I connect the switch, it's here. What is the voltage V1? The voltage across the 20 ohm. Now, we need to get benefit of the reduction that we have, would happen in the circuit. As a matter of fact, the reduction that we do help us to find the other electrical quantity in the circuit. So I will go for the last circuit I achieved, which is this one. And here I will have my 50 volt. And this is my V1. This is here my V1. Because the 20 ohm and the 10.67, they were in parallel. So they share the same voltage. And the equivalent resistance, which is the 6.96, will also have the same voltage V1. Okay? So basically here I have a voltage supply connected in series with two resistors. And I want to find V1. The best way is to use a rule called the voltage division. What is the voltage division? That the V1 is equal to the main voltage, which is 50, times the resistance across which I want to find the voltage. So I have two resistors in series here. So basically, I am interested in the 6.96 divided by the summation of these two resistors, 10 plus 6.96. And if you do that, you will find that the voltage is equal to 20.5 volt. Now, when we can apply this voltage division, when the voltage supply is in series with two resistors. So when it is with two resistors like this, then the voltage across one of them is the main voltage times that specific resistor divided by the other two resistors. Now you can apply different rules here. You can apply KCL and KVL, but voltage division is found to be very easy to deal with because you can find the voltage in one step. But if you are not comfortable, you can use the classical techniques like KCL and KVL. So that is basically how we approach a circuit reduction question. I will have one more question, but with different requirements in the coming video.